Здравейте, БГ джуговци и БГ джуг девойки. Днешната лекция е част от пътешествието на Foojay. Ще разберем малко по-късно какво е Foojay. Гертян ще разкаже повече за новата инициатива и за няколко минути преди лекцията на Стивън Чин. So now we switch to English and Gert-Jan is going to, hi Gert-Jan, you're going to say a couple words about the new initiative and what it's about and what's the purpose of it.
Exactly. Thank you so much for having us. I'm going to share my screen and I hope it looks good. So what I'm showing you right now is Foojay. And Foojay is a new community website for anyone doing anything with Java. So if you're any kind of Java developer, you'll be interested in finding out which OpenJDK distributions there are. And you'll be interested in finding out what fixes are part of the many quarterly updates that have been released over the years. And if you're a Java developer, you're interested in knowing what the JVM command line switches are. So that is what Foojay is for. And I work at Azul. And Azul has taken this initiative to put together the starting point of a Java community platform. You're very warmly invited to join in. Other organizations who are involved with this project, apart from Azul, are Datadog, where you'll find someone like Marcus Hurt, for example, who works on the Java Flight Recorder. DataStax, Peter Humphrey, well known maybe from Pivotal and Elastic, and now at DataStax. Hazelcast, so there's Nicholas and a number of other great Java developers involved in Foojay. Jfrog, of course, Steve Chin, who you'll hear from in a few minutes, and Ari Waller, who is the person putting together this tour. So right now we're going to a lot of different jugs during the previous month and this month to introduce Foojay. And Jfrog is the organization that is primarily involved in putting this tour together, in particular Ari from there. And in addition to Jfrog, Payara is involved. So Steve Millage, a lot of people might know about in that context. And also Simon Maple and Brian Vermeer from Sneak. So all across the Java community, there's been a need for a number of years to have one common place where we all go to for all our information. And that is what Foojay is. And what it means, what it stands for, is a place for friends of OpenJDK. So if you're using Java in some way, you'll be interested in this kind of reference material, or you might be interested in having a daily tip or highlight or blog. So there's a daily article on the Foojay blog called Foojay Today, and you're very warmly invited to join in. So if you have technical Java content, you're welcome to blog here. You'll find there is also an event calendar with events. So jug events and so on can be posted here. There's a terminology section. Does anyone know what the TCK is and why it is important? What are CPU and PSU releases? So these are typical Java terms. You'll find also that there is a tweet area, and of course there is Twitter. So if you want to keep up to date with what's going on in Java and you want to contribute to the Java community, you'll follow Foojay. Foojay.io is our Twitter handle, and just follow, and every day you get a new tweet with a new Java tip and so on. Of course, there's a Slack channel, so you can get involved and join in with providing content. So this is where we discuss the content of Foojay or general Java topics. Do you have questions about Java? Are you stuck on some problem when you're doing your Java coding? You can join in on the Foojay Slack channel and discuss with Java experts from around the world for free about your Java problems. So it's really the place to go to for all your Java requirements, one-stop shop, collaboration platform, integration of all kinds of different content. And that's why we're doing this tour, to introduce you to Foojay and to introduce you to some of the people who are involved with it. And so with that, I'll hand over to Steve for the next talk in the Foojay tour. You'll see there's many more coming. on DevOps tools for Java developers. So over to you, Steve.
Hey, thanks, Kirchen. So very, very glad to be able to be speaking at the Bulgarian Java user group. This is a great privilege. I've meant to come out there. You guys have a great user group and also a great conference which you've been running, JPrime, which I've always wanted to be a part of. But I guess virtually is going to be the first time now.
You like riding motorcycles, right?
I do, yeah. How about you guys?
I do too. So the last time we spoke on at JCrete, there was an invitation. I extend that, I repeat the invitation again. So we'd like to have you here. And I know you've done a European tour, right?
Mm-hmm.
And it's a nice place to ride. So next time you do Europe,
I'll be out there. I was planning a European tour with Mateus. Mateus and I were thinking we should do a Europe tour for the next one. So maybe it'll be an opportunity to meet in person via motorcycle. That'd be a lot of fun.
Sure. We would like to have you here, especially if it's close to JPrime, so we can do a session too.
Very nice.
Because the weather will be perfect.
What's the best time of year for riding out there?
Late spring, early autumn. So or summer, but it's going to be a bit hot. It goes up to more than 100 degrees Fahrenheit. So it's going to be
cool.
a bit hot. So and everything is the color. It's colorful in late spring and early autumn.
That's nice. Okay. I'm looking forward to it.
Okay, I'm going to switch your screen on, and here you go.
Cool, thanks. So I think a year ago I'm going to talk a bit about DevOps tools for Java developers, but before that, a year ago I think we were all had very different impressions of what was going to happen, and I don't know about you guys, but personally, when I heard that there was a pandemic and a virus going around, I figured somehow it'd be a lot cooler than it turned out to be, and we'd all be maybe vigilantes going down the freeway, fending for ourselves with our pet dog behind us. Unfortunately, I think it for most of us it ended up more like this. So this is my usual setup. Why get dressed when you can be comfortable in a bathrobe? So I have a few monitors and microphone and camera and all the things which you need to do work and broadcast. Set up from home now, and I think we're pretty fortunate in the tech industry that we can continue to do our jobs, be productive, build great software directly from the comfort of our homes. And one of the projects which I took on in the past year, since we have some more time, is writing a new book. For anyone who's interested in writing a book, I would highly disrecommend it. It's a lot of time, and it's not very financially rewarding. You'd be better getting a part-time job at McDonald's or your favorite restaurant and make more money. But the book which I'm writing is called DevOps Tools for Java Developers, and I think it's a great way to share your knowledge with other people when you write a book. So don't do it for the money, do it for the passion. So a lot of the content which is in this presentation is directly from the DevOps Tool for Java Developers book. And also we have a raffle for attendees. So JFrog's well known for t-shirts. When we go to conferences or when we do events, we always have t-shirts with us. And during the pandemic, we're shipping t-shirts all across the world. So we're going to ship 10 t-shirts to Bulgaria for some of the winners today who enter the raffle. If you go to that URL, jfrog.co/bgjug, all the slides are here. There's a raffle where you can get some of the t-shirts, and you can opt in or opt out for emails. So if you're not interested to get marketing emails, just don't check the box and you'll be fine. Okay, so I'm going to cover a bunch of different topics today. So I'm going to go through a little bit about the history of source control and best practices for managing your repositories, continuous integration, so how you can get your build set up, package management, so how to manage your binaries, get full traceability of your builds, a little bit about security scanning and why you should care about doing more security scanning and shifting security to the left, and a little bit about continuous delivery for deploying releases. We won't do these exactly in order, but I think this should just give you a good breadth of different topics, and all of these are covered in more depth in the book. So I'm going to give you kind of the highlights and point out some things which I think are interesting in each of these areas, such as the history of or evolution of mankind towards modern version control systems. So I'm probably dating myself, but if you're watching in the chat, type which version control system's the first one which you used. And for me personally, this was RCS. So RCS is one of the first generation version control systems. It's a locking version control system where you basically have to lock every file when you want to edit it, and then you unlock it so other people can edit it. It has its origins basically in people doing things on mainframes where you would all have a shared file system, and then you have to lock files from other people editing at the same time. And it's absolutely horrible. So if you want to work together with people on a project, they can't touch your files until you're done with them, and you have to organize your code base so you have as few dependencies which go across multiple files as possible. Otherwise, you're stomping on all the locks across the system. The evolution of this was CVS, Concurrent Version Control System, where now we had this modern concept and the ability to have multiple people editing files simultaneously without locks. And we're assuming that there's no conflicts between different people editing until folks check in, and then we realize there's a conflict, and then you deal with a merge conflict resolution at that time. So this was a pretty big shift from the locking version control systems. Even a decade after optimistic version control systems came out, we still had a lot of commercial version control systems which employed locking mechanisms like Perforce and some of the Microsoft tools. A bunch of the commercial version control systems were slower to pick up with concurrent locking and merging. Yeah, Star Team's probably another one. I think that was probably originally a locking version control system. Thanks for everyone who's responding in the chat on what they're doing. Subversion, I think, is the natural progression of this. It was the kind of a better version of CVS, less issues with the server, where you would conflict with each other and cause issues with the file system, or the scanner would get stuck less often. And then I think where most of us are today is on the third generation of version control systems, which are distributed version control systems like Git and Mercurial, which Bazaar is another one, which we'll talk about in a bit. But if you look at the adoption of version control systems, really, Git as a version control system more than the concurrent version control systems, more than other distributed version control systems, has kind of taken over and become dominant. And that's for a lot of reasons, but I think it's very high performance. It allows you to sync files with peers and also with central servers. And a typical pattern for how you would use Git and distributed version control system is like this. So you'd still have a central remote repository. Often you'd host this on shared infrastructure like GitHub or Atlassian's Bitbucket or GitLab. Then you'd fetch files, so you'd have a local repository where you have the entire local repository on your machine. Then you check in and out from your local working. You pull a working copy and check in and out from your local repository, And then eventually you push changes to the remote repository, and you can fetch changes from the remote repository. It's also possible to sync files outside of the remote repository with other peers if you're working on a project and you don't want to push it. It's possible to do stuff entirely remotely, where you can kind of be off the grid and be doing stuff just with your local repository for a while. I think the only thing you need to be careful about is if you're doing any stuff with rewriting history, you want to keep that all local before you push it to the remote repository, because if you rewrite history in the remote repository, now you're affecting everybody, and that can be pretty dangerous. And then as far as usage of tools across the industry, GitHub and other tools like Slack, Jira, Google Docs have pretty much are the most popular tools across the industry. But you see there's a lot of Git tools in this list. So GitHub, GitLab, Microsoft Teams, which also supports Git. So you have a lot of different tools for managing version control system, which are at the top of the list for the most popular developer tools, according to the Stack Overflow survey. Now, if you're using Git, you're probably using one of these integration patterns I'm going to talk about. The most kind of the granddaddy of all the integration patterns for managing branches is Git Flow. This is also the most complicated one for how you manage your branching strategy, typically with a half dozen or more different branches going on simultaneously. And the basic flow here is you have a feature branch, so a branch per feature. So this is common with most of the Git strategies. But in the case of Git Flow, you also have branches for releases, you have branches for hotfixes, you have branches for a master where you're tagging things. And really where Git Flow shines is if you're doing development, where you have multiple releases that you need to patch and support in parallel to each other. So this would be the case with typical client software development. If you're doing any sort of release software, where you have to keep like a version 1 and a version 2, both in parallel with releases, with ongoing development, and with patches going out. So I think this is kind of the uber set of branches and strategies you can do to maintain very, very large, complex software. But usually for projects, the other attribute of Git Flow is that history tends to get a little bit messy because everything's done pure with no history rewriting. So you tend to have a lot of work going on in branches and then integrating back again, and lots of merge conflict resolution. Something else which I think a lot of the more modern ways of managing Git history encourage is doing either fast forward merges or rebasing of history, so that your history is a little bit more linear when other folks look at it and try to figure out what the changes are which go into it. But I think this is a bit overkill if you're building software for the web, if you're building things which basically have one latest version. So more appropriate branch management strategies for those would be something like GitHub Flow or GitLab Flow. Both of these have, again, feature branches, so branch per feature. But where they differ from Git Flow is they really have one master branch, so they don't have release branches, they don't have tagged branches. And you're basically integrating everything into one master branch, which you also release from. So it simplifies the flow, and then you can just tag releases as they go out. In the case of GitHub Flow, which came first, they were also not recommending rewriting history or doing fast forward merges, but GitLab Flow and a lot of the newer Git branch management strategies recommend doing a lot more merging and rebasing. Okay, so it was a little bit about version control. Hopefully folks are either using Git or are inspired to move up to a distributed version control system now. I think the next thing after you have your source control available is you have to now be building it and integrating it on a continuous basis. And typically this would look something like having a continuous integration server, which is pulling from your source control repository. So this could be Jenkins or Circle CI, or we have our own CI/CD tool called Jfrog Pipelines. The CI/CD server would then build the software into environments when different metrics are hit, when different quality requirements are hit. So you'd build an integration server and then do maybe acceptance tests or some integration tests which on that server. Then move that into a system testing environment, do additional testing on that. Then it might go into a staging environment before it hits production, which is, a scaled down or environment which most closely is a replica of what's going to actually get pushed into production. And again, if all the quality metrics are hit for that, then it would go into production. And ideally, what you want to happen is all of this should be automated from the time you check code until it goes into production. Everything should be running in automated fashion. And you should have sufficient quality measures in place to ensure that by the time things get to production, there's as few defects as possible. Or you have a good rollback strategy so that if there are issues, you can roll back to the previous version very quickly. And when you don't have automation or when you don't have an effective rollback strategy, what can happen is you can end up like the unfortunate folks at Knight Capital, who are a classic case of kind of manual deployment gone wrong. So Knight Capital is a company which built trading software. And they had a system where they were releasing new software for doing high frequency trading. And the release was going out the morning the new system was set to go in place. They noticed that there were a bunch of erroneous trades going on through the system and assumed that it was a result of the software update they'd made the previous week. So they tried to roll back the system. Rolling back the system actually made the problem worse, and it took them about an hour to get to the root cause of the problem, which cost them $440 million. They were erroring out a rate of about 10 million, a cost of $10 million per minute of system failure. So it can be very expensive, especially when you're in different industries, when you have big failures. And so what happened with Knight Capital is they did a bunch of things wrong, but one of them was reusing APIs. So on the server, they'd reuse some APIs which had been for a deprecated feature, and they reused that for the new trading system. The clients were updated to take advantage of the new API. The server was updated to take advantage of the new API, but on their server farm, it was a manual deployment, and only 7 of the 8 servers were properly updated. The last server was the one executing erroneous trades because it didn't have the new code for the new trading API. When they did the rollback, they actually made it worse. So they made all 8 servers start erroring out instead of just 7. And when they finally got to the root cause of the problem, they realized that it was actually an issue with deploying to all the servers. They redeployed the new version to all the servers, and they were back up and running, but with a huge cost that eventually cost them the company. They had to restructure the company at the end of the year and then merged with another company to become financially solvent. So that's a little bit about why you need to build continuous integration. Why you should care about this. Now, I think the other thing that you should really care about as well, and we're going to get back to package management in just a sec, is security scanning. And security scanning is another one of those activities where not doing good security practices, not making sure that you're updating constantly is something which you need to, you can pay big penalties for. And in the modern era, this is somewhat analogous to historically what folks had to deal with for oil spills. It has a similar impact on your company if you run into security vulnerabilities. So speaking of oil spills, let me give a juxtaposition between a classic oil spill, which we just recently resolved, and then a little bit about some software vulnerabilities which also affected the industry. And I guess the question is, which do you think is more damaging in terms of financial impact? Okay, so here's the oil spill example. So this in the Gulf of Mexico, there's a large oil platform built by Taylor Energy. This oil platform was hit by Hurricane Ivan back in 2004, and it ended up leaking about 300 to 700 barrels per day, although they estimated a much lower number. Initially, it took some doing resurveillance to figure out that it was actually a huge issue. And the challenge with oil spills and oil platforms is it's very hard to get to the ocean floor to do the oil cleanup. So typically whatever the disaster is that causes the oil platform to collapse causes a huge issue, both with covering up the pipes and the areas you want to clean up, and also it's hard to access because it's very deep underwater. And so eventually it took them, they spent $435 million in cleanup, and they never entirely fixed the problem. So we'll talk about what the eventual resolution was for this. But this, for Taylor Energy, this was over $400 million in damages. And if you look at open source projects also have a lot of vulnerabilities where we're all using open source software. And about 99% of enterprise projects are using some form of open source software. And of those open source projects, 72% of them contain at least one vulnerability. So and there's about 82 vulnerabilities on average per code base. So if you're using open source software, which you should be, because that's really the best practice and the best way to make sure you're using modern libraries and technologies, and also getting updates for vulnerabilities. If you're not staying updated, you can be exposed to a lot of legacy vulnerabilities. And if you take like a Docker container or any deployment, let it sit on the shelf for just a few months, you'll see hundreds of vulnerabilities pile up in that repository, simply because there are constantly new vulnerabilities being discovered and being reported, and you have to patch them very quickly. And when you don't patch vulnerabilities very quickly, you end up with situations like what happened with Equifax. So Equifax was hit back in 2017 by an Apache Struts vulnerability. This vulnerability, kind of in a scary way, is actually still in the wild. So there's still, legacy implementations of applications which still exhibit this vulnerability at CVE 2017-5638. And it allows you to get access to the machine which your web server is running on top of. And in the case of Equifax, they knew about the vulnerability. They actually patched the vulnerability on their main servers, but they had some additional servers which were doing other community work which weren't patched, and attackers got into their network via those other servers. They were able to do some internal hacks to get data around the internal network and get access to the databases of customer information. As you know, Equifax holds all the information for consumers throughout the US, so a lot of private information. And there were 143 million customers of Equifax who were affected by this data security breach, because the hackers, after a few months in the system, started exporting large volumes of confidential information outside of the network before they were eventually caught. And they traced it back to this Apache security vulnerability when they figured out how the attackers got into the network. So in the case of Equifax, it cost them $1.4 billion in cleanup costs to fix this issue, and $1.38 billion in consumer claims. So it was several orders of magnitudes worse than the Taylor oil spill, just on a security vulnerability which wasn't patched holistically across their entire platform. Eventually it was discovered, and this last year, the beginning of last year, they actually indicted some Chinese military members for doing the security breach. So they believe this is actually a government hack, not a private hack. So there wasn't actually any examples of the private consumer information showing up on the dark web. It was all probably used and entirely for espionage and government purposes. But nonetheless, it was a huge blow for Equifax as a company, Just like the oil spill was a huge blow for Taylor Energy. In the case of the oil spill, just to close this out, this was the eventual system which they put in place. So they actually built a specialized oil containment system that they lowered to the floor, which traps the oil. This has pipes which connect to it, which are used for retrieving the oil remotely. And then they have ships sitting above the Taylor Oil Energy site, which catch the oil. They bring it back to shore, and then they resell it after they clean it. And this also stopped the occasional plume of oil slick, which was happening, which was persistent before they put the oil system in place. So hopefully you're motivated to integrate security scanning into your overall DevOps strategy. You don't want to end up like Equifax with billions of dollars in risk. And from a company standpoint, this is also something that you can do as developers now, because a lot of tools like JFrog X-Ray, which is our security scanner, allow you to scan and then get information right back into your IDE or into your release system, and then put builds on hold or get notifications right at the time which you're developing and using a vulnerable library. Okay, and then the next practice we're going to talk a bit about is continuous delivery. So releasing more often, releasing to edge devices, and constantly deploying. And if you think about why continuous delivery matters for software developers, really everything which we use in our lives it relies on constant updates. So your smartphone, all the operating system itself, and all the apps on it are constantly being updated, and you expect and you demand more features on your phone constantly. So the ability to have constant supply of new software releases and new updates is an important part of the app ecosystem. Also, being able to have other integrated devices like maybe your smart app on your TV, or a smart fridge, or even your car, all updated and operating smoothly is a very critical part of all of our lives. And in the cases of cars, you also need to make sure it's secure, updates successfully, and doesn't cause any safety issues as well. So as a consumer, how do you choose when you want an update? We've already established that. I think we all want updates on our devices. We all want updates in software, and we kind of expect this in the modern age of web applications and IoT devices. So here's a flow chart kind of going through the thought process of how consumers and folks think about updates. So the first question is, when update becomes available, do you want the update? A nice shortcut for this is if you can make updates mandatory. That's an easy way to get folks to simply go from updating all the way to actually making the update. But sometimes consumers may choose to skip updates. I think a lot of folks kind of delay updating their phones or other devices because they've had a history of breaking issues, or your laptop operating system might cause breaking issues as well. But assuming you want it, then the next question is, how risky is the update? If you've done updates before, or if you believe the risk is low, then you go ahead and you update it. The next question is, do you trust the update? So is this something which you trust the person making the update? And if you don't trust the person making the update, can you verify it? And in the case of software dependencies, it can be very costly to verify dependencies and recheck your entire system every time there's an update. And a perfect example of this for all of us is the Java releases. So when a new Java release comes out, the question is, how costly is it to verify your code to make sure it works for the latest release? So back in 2017, Mark Reinhold at DevOps Belgium announced the new release model, the new OpenJDK release model, where we're going to have releases every 6 months, starting with Java 9. And this is something which I think for a lot of us, the pace we expected Java releases was every 2 to 3 years. And now you are getting very, very frequent releases with lots of updates, lots of changes, and then deprecation of APIs. So one of the questions is, now that we're getting releases more often, are we taking advantage of releases? So in the chat, if you wouldn't mind, let everyone know what version of Java are you currently deploying on? So are you on the latest version of Java? Are you on the latest release, the last LTS release of Java, or are you still on, Java 8 or something previous? And don't be shy. Let's take an informal poll and see what version of Java folks are actually using. So this is the poll which was taken recently in one of the Sneak surveys, and this tells you kind of where folks are. So thanks Stanislav. You're in the majority with Java 8. Java 8 was, I think, had a lot of features. It was actually a great Java release, a very stable Java release, and it had the highest adoption of any Java release in the recent history. Much higher than Java 7 and more modern releases of Java. Obviously, it's a little bit unfair because they happen more often. And it's been a very stable release for folks. But Java 11, the new long-term support release, and thanks Stefan as well for replying on that. This is kind of the golden standard if you can make it past modularity in Java 9, which I think was a struggle for a lot of projects. And if you're an open source project, the recommendation is always support the latest version of Java. Plus the last LTS release. So Stefan is on Java 15 as well, so that's awesome that you're updating to the latest JDK releases. Java 16 just came out, and when Java 17 comes out, that will officially mark the next LTS release. So in a few more months, when Java 17 comes out, if you haven't made the upgrade past Java 8, that's a great opportunity to kind of invest and start looking at doing that. And I think this is kind of the thought process when you're looking at JDKs, if you look at the same thing. So a new Java release is updated. Do you want it? Well, hopefully you do because of all the new performance fixes, features, and capabilities. Is it risky? Well, yes. Do we trust Oracle? Well, no, we want to verify it. And when we go and verify it, this can be a very costly verification based upon how many automated tests and how quickly you are able to verify the new release. So the advantage of the quicker release cycle is the amount of verification, the amount of change is lower, but the disadvantage is that you have a lot more releases to test and a lot more occurrences of this happening on a regular basis. So this is a little bit about Java releases, but I guess the question is, if you're not updating frequently, and if you don't have a good automated process for doing this, what can go wrong? And this is another example of what happens when you don't have the ability to do verification in an automated way on a large scale system like Cloudflare, which is a large CDN. And so again, there was a big outage with Cloudflare where they had about a half an hour of downtime. It was essentially the equivalent of a global turn the lights off as a result of their network getting overloaded by a code change. And so I'm gonna put the code change up. So this is the actual code change which was deployed to production for Cloudflare. It's a regular expression, and as you guys all know, regular expressions are not the easiest things to decipher and fix. But there's a problem with this regular expression, which caused it to go out of control, and to consume all the memory and resources on Cloudflare's content delivery network nodes, which this was deployed to. And again, it's hard to verify regular expressions. It's hard to make sure that you don't have bugs in your code. And so for anybody who's a regular expression guru, you'd notice that this end section in red is suspect. And You can simplify this a little bit by getting rid of the capture group. The capture group is just going to determine what you get out when you're doing replaces. And then it simplifies to just a double wildcard followed by equal and another wildcard. And if you're a regular expression guru, you would know that for a lot of regular expression engines, double wildcards are have exponential complexity. So to figure out what it should return from this on a small string set, it'll do fine. So if you tested this on a very small document, it will return in a reasonable amount of time. But then if you had an extremely large document passing through the network, this would require very high complexity to fix. There's some newer regex expressions which fix this problem specifically, so they can do this in constant time rather than exponential time. But in the case of Cloudflare, this actually consumed all the resources and memory on their servers and ended up doing a kind of a global outage. For anyone who figured out the regular expression issue, you are definitely in the genius category. But I think most of us would agree that if you tried to figure this out in a code review and you didn't have a good automated test suite to test different document sizes and documents before deploying this to production, the chances of this blowing up in production rather than getting caught in your earlier testing phases is extremely high. Okay, now the last topic we're going to go over for a bit is package management. So package management is something kind of near and dear to our hearts at JFrog, because this is one of the things which JFrog has done well for over a decade with managing binaries and managing dependencies, and having the best artifact management system for supporting all different languages and package types. So it supports Java, of course, supports modern languages like Go and Kotlin, and supports a wide breadth of cloud native technologies like Go and over 26 different package types. So it's kind of the Switzerland of DevOps, supporting a wide range of different package types and integration technologies. And having good flow for your binaries is important for your entire system, because when you're doing releases, when you depend on open source libraries, you need a way to figure out what those vulnerabilities are and trace those back to the root cause, and then more easily identify and fix issues before they become a problem. So if you look at our overall platform, the Jfrog platform, it covers all the things which we've talked about so far in this presentation, minus source control system. That's the one thing which we rely on other folks for. So once you have your source control set up, you can use Artifactory to pull in different dependencies, and then you can use JFrog pipelines to do your actual source control builds. JFrog X-Ray does security scanning of vulnerabilities and can report back information. It ties into a bunch of different external security vulnerability databases. So you have a big widespread of different vulnerability systems which you're checking, in addition to our own vulnerability database, which we have experts who maintain and check on a regular basis. And then all the way to distribution with JFrog distribution and Artifactory Edge services to get your devices to get your releases to different devices like your car, your phone, or even large Kubernetes clusters or different edge deployments which you have set up. And we integrate with everybody from different CI/CD tools to source control tools to dependency managers to different build tools. So basically whatever technologies you're using today are things which we integrate with. As I mentioned earlier, we have the raffle going on, so you can win a set of 10 t-shirts, which we'll be raffling off. And also for the Bulgaria Jug, we have a special version of our product, our free tier, which you can use the first URL, bgjug_free DevOps tools, to sign up for. So the free version of our tools includes Artifactory, pipelines, and X-ray security scanning. It has a free quota each month, which you can use entirely free. It's enough to develop as an individual developer or a small team without paying anything. And it's a good way to get started with building your overall DevOps pipeline and starting to get started on your road to being better with DevOps and having a better continuous integration and delivery pipeline. So hopefully everyone learned a bit about DevOps today. This was just a high-level overview. More details coming in the book, which is going to be released soon. We're just finishing our final drafts this month. I think it's slated to be released later this year by O'Reilly. But it's been a pleasure being able to come out and to speak at the Bulgarian Java user group. Thanks to everyone who answered questions in the chat and responded to some of the stuff which we wanted to take polls and engage with folks. And also a big thanks for Foojay. I think Foojay is one of the best places to find out more about the JDK, find out what OpenJDK version you're using, and also to connect with other Java developers and to share your knowledge about different Java technologies and what's going on. So we also support the DevOps forum on Foojay and have a bunch of content coming out there on a regular basis, which my colleagues Melissa McKay and Baruch Sedigersky maintain. So thanks everyone. And if you have any questions, feel free to reach out and chat and say hi.
It was a great session. Thank you. Guys, if you have any questions, you can use the chat and you can ask them here, and we can ask Steve. So let's see what happens in the chat. Gerten, I wanted to ask you, why did you start Foojay?
Well, it's a long story, but clearly something like this has been missing for a long time. We haven't had something like this. When I was working in Sun Microsystems, we had Java.net. And that was the place everyone would go to for all their Java information. But since then, we don't really have that. So I started working in Azul about exactly 1 year ago. I joined Azul especially because Azul wanted to take this initiative to contribute to the community. And because Azul itself needs a source of information like this for people inside Azul. And so it's a way to work with the community, to create something and to make it available and to collaborate around that. And that's something I've been doing all my life in the Java ecosystem. I mean, I'm still working in the NetBeans community. It's an active community on Apache now, but this is very similar to that because it's also collaboration and contributing and providing educational resources and supporting free open source software in Java. So I feel this is a really good place to be, and I think Foojay is a really great thing. I wouldn't be involved in it otherwise.
Thanks. What is
I want to.
Sorry.
I was just going to add to that I think the other big problem which Foojay solves is since the change in release models for the JDK, there wasn't a really good place to go for information about different JDK distributions. So there was a lot of misinformation. And I think that just having a place where you have so many smart people, Java champions, folks from the community engaging and sharing knowledge, it kind of raises the bar for the whole Java community. So it makes it so that all of us in the community are much better educated and making better choices about the JDK versions we use, the dependencies and open source libraries we're using, and how we're approaching software development. So I think it's of huge value to the community, and I think it's awesome that folks like Kirchen and myself after leaving Oracle are still engaging the Java community and helping to move things forward.
Yep.
I remember when there was this rumor or this news that Java is no longer going to be free, and everybody was freaking out, and major people were putting in mail lists. Listen, guys, Java is still free, and it was funny to watch. It was funny to watch.
Yeah, no, I mean, and it's, if you remember, it's the Java community. It's all the Java community leaders who rallied to support it. So it was a licensing change, but for the community to understand it, it really took some smart folks in the community to break down what it really meant for like getting the latest versions, getting patches, getting updates. If you couldn't afford or didn't want to get a commercial license from Oracle. So I think it was great that the community broke it down and figured that out for everyone. And it prevented what could have been catastrophic, which would have been an exodus away from Java if folks didn't see a good free solution for going forward.
Yep.
Steve, you froze.
Oh, sorry.
Can you repeat the last sentence?
Yeah, what I was going to say is if the community hadn't rallied together and figured out what the new release model really meant, it could have been catastrophic for the community, where we would have seen an exodus away from Java. And fortunately, now there are so many great community alternatives, like Azul from Yurchin's. I mean, not Azul. Azul makes Zulu, which is their OpenJDK distribution. You also have similar offerings from Amazon, from Eclipse, from a whole bunch of other organizations which provide free or different support options for the JDK. And I think more than any community, the Java community is very independent. So it's great that the community is out there building new sites and resources like Foojay, and even like this Jug Tour we're organizing.
One of your slides showed that the majority of people are still using Java 8. What do you think is going to push them? Yeah, because the big thing is when you get to Java 9, yeah, okay, it gets a lot easier, right? But what is there a solution to the problem when the majority of people are still using Java 8?
Yeah, so well, I mean, first of all, you're assuming it's a problem. So, actually, a lot of you can get stable releases of Java 8 with backported bug fixes for all the security vulnerabilities. So it's not it's currently possible to be on Java 8 and to be secure and have stable software. So it's not a problem. I think if you look historically at what's driven developers to update on Java releases, it's always been features.
Exactly.
Right? So Java 8, in terms of the features and like what it brought to the language, was huge. So the benefits of upgrading to Java 8 outweighed any of the downsides of retesting or fixing releases. And I think what's really needed for the Java community to move forward is modularity. I would look at in general. That's a feature which was kind of built to better structure the JDK. But for the majority of use cases, developers don't need modularity themselves. They use it from libraries or from JDK, which kind of are better structured as a result of it. So I think what'll really drive developers to upgrade to the later releases is features and improvements in the Java language, which matter. And historical projects like Project Coin, which add in a bunch of cool language features, or major language features like generics or lambdas or other big features. That's what developers upgrade for, is having the really cool features. So I think there's some stuff on the horizon which is really cool. Like if you look at some of the upcoming work on I'm forgetting the name of the project for the fibers, the lightweight threading. That's really cool technology, which will change the way in which we build server-side libraries and technologies by having a much more efficient threading model. I think it entirely kind of displaces the need to do awkward things like kind of the Node.js event-driven style architectures, which are hard to maintain. So I think that's one of the big things which in the future we'll see libraries and frameworks which if you're not using a version which supports like fibers and that level of concurrency, then you won't be getting the best performance out of releases, and people will upgrade for those reasons. And then other stuff like the work going on by Brian Getz on having more efficient data structures as well. Exactly. There's a whole bunch of like cool features which are in the works, and I think as we see those coming into the JDK, it will be too hard to not take advantage of that new work. And I think the other thing is folks are getting used to the LTS model. So Java 11 was the first LTS, but I think at the time folks hadn't really kind of understood what an LTS was. We also didn't have enough of vendors supporting LTS releases, and the Open JDK model was upgraded to the latest release every 6 months, which if you think about it from a corporate software standpoint, you can't not have security patches when the next version of Open JDK comes out. Right, you need to get security patches continually while you're working on upgrading and testing the new release. So that's what all of the OpenJDK distributions do, is they give you a stable, safe version, and the next version, Java 17, I think will get great adoption. Everyone who's on Java 11 or another OpenJDK release will definitely upgrade to that. And I think it's also, if you were waiting for a time to upgrade from Java 8, it was probably Java 17.
Because of records and fibers.
Well,
mostly.
Yeah, well, I mean that, and also having an LTS release, right?
Yeah.
Today is very easy to use LTS releases, to jump between LTS releases, because the changes are already present. Most of the changes are already present in the intermediate version. So moving forward is not that hard like jumping from Java 8 to Java 9.
Yeah. Once you get past Java 9, you're good.
Yeah.
That's a big leap for a lot of folks still.
Yeah.
Duchin, you have any questions?
No,
or?
Not really. So I would like to thank you, both of you, for joining us this evening. For us, evening for you. For Steven, it's probably early in the morning. And thank you guys for being here with us. Michiel?
Yeah, the whole thing is going to get recorded, and it's gonna stay on YouTube. So it's going to be available, when we publish the recording. So yeah, it was great having you guys here.
Thank you so much.
Thank you for your time, and I really hope, Steven, you can join. We'll find a motorcycle for you when you can.
Okay. Yeah. No, I'll take you up on that offer. I'll definitely come out.
Sure.
For J Prime, I think I have my invitation, right?
Yeah, definitely. I'm going to push for a date close to J Prime.
All right. Cool. Thanks so much, and it was great being able to speak to the Bulgarian Jug. So you guys are doing an awesome job keeping things going.
Yeah. Thanks.
Bye.
It was hard to adapt to a remote model, and we preferred the real thing, but currently it's not possible. We managed to do only one drive-in event where we park cars, drank beer.
Oh, nice.
Well, Girton, I know you're having a beer also, so yours looks empty. And it was hard to adapt, and I really hope that soon we'll be able to see each other live, because it's better to be close to each other.
Everybody from the community are waiting for the time when we'll bring back our Java beer event.
Yeah.
Nice.
And do no sessions, just beer. The sessions are just an excuse to get and drink beer. Yeah. You're welcome. You're welcome. Yeah, always welcome. Yeah. Okay. Thank you guys. Thank you.
All right. Thanks so much.
Bye.
Bye-bye.
Yeah. Bye.